Good morning. Today we are moving on with our unit. Devices are close up. CO24. I can find the least common multiple of a set of numbers. So yesterday we talked about the greatest common factor. Today is the least common multiple. So we're not working on breaking it down into its factors. We're looking at what it multiplies up into. So factors, remember, are a number that goes evenly into the given number. So an example would be factors of 12. We know we have our factor buddies of 1 and 12, 2 and 6, 3 and 4. Those are factors, looking at those factor buddies, factors of 12. Today we're switching gears and we're looking at that least common multiple. So a multiple are numbers a given number can go into. And this is found by skip counting. So an example would be multiples of 3. We would skip by 3's. 1 times 3, 2 times 3, 3 times 3, 4 times 3, 5 times 3. So we're skipping up by 3's. Multiplying by 1, by 2, by 3, by 4, by 5. So we've got 3, 6, 9, 12, 15. Do multiples ever stop? No. Remember, that number line goes on for infinity. You can keep doing those multiples for infinity. That's why we look for the least common multiple. Could we ever find the greatest common multiple? No, because numbers go on forever. You could have huge multiples. 1,555,000. They can go on forever. So those multiples go on forever. So when we're working with multiples, we always look at the least common multiple. Madison.
So when we go down to the...
Oh, we'll get to it.
Oh, okay.
I love that you're looking ahead, but I'm getting to it. So we need to know the difference between a factor that we worked with yesterday and the multiples. So factors of 8. What are the factor buddies for 8? Callie, tell me one.
2 times 4.
Tell me the other one, Marina.
8 times 4. Oh,
Okay, so those are the factors of 8. Those are the numbers that we multiply together to get to 8. Now we want the multiples of 8. 8 times 1 is what? 8 times 2? 8 times 3? 8 times 4?
32.
Those are the multiples of 8. Very different kinds of numbers, right? Factors are limited. These are the only numbers that 8 is divisible by. Multiples, we just keep multiplying up. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6. It can keep on going. 8 times 100, 8 times 101, 8 times 102. Those multiples keep on going. We are skip counting by 8s, on and on and on. So, what are the factors of 6? Zelda.
1 times 6 and 2 times 3.
1 times 6 and 2 times 3. But what are the multiples of 6? Starting with the 1. Melanie?
6, 12, 18, 18, 24, 30.
And let's stop there. Because it goes on forever. I could ask Melanie to keep on going, and she could keep on going. 36, 42, 48, 54, 60, 66, 72. Oh my goodness, we could keep on going forever. So we always, when we're working with multiples, always start with 1, 6 times 1, and then we're skip counting up. 6 times 2, 6 times 3, 6 times 4. So how do we work with multiple numbers, finding that least common multiple? So let's scroll up. There are 2 different ways we're going to find that least common multiple. The greatest common factor, we talked about 3 different methods. We're going to talk about 2 different methods to finding that least common multiple. The first one is our listing. So we have the MCL. We're going to find the multiples. So we're going to list the multiples. We're going to find the common multiples that they share. And then we're going to find the one that is the least. So first, we find all the multiples for the numbers. Then we circle which ones they have in common. Then we circle the least. Now, when I start doing my list, I start by going out 10. I go out 1 times 2, or times 1, times 2, times 3, times 4, times 5, times 6, times 7, times 8, times 9, times 10. So I go out to the 10, and then I do it for the next number. I go out to the 10. I look to see what's the smallest number that they share in common. Then we have our table method. We talked about that table method yesterday. I have that table method as part of the word wall. So I brought it back up here. I didn't bring it up yesterday. We just worked on the board what the table method was. So we've got the same table method that we used yesterday. So we would put our 2 numbers. We would put our 2 numbers on the top, just like we did with the table method for the greatest common factor. We made our table. With the greatest common factor, we were pulling out those primes. We're going to do the same thing, but we're going to add one more step to that table method. So I'm going to walk you through how to use the table method, just like we did with greatest common factor, but it's not finding the greatest common factor, it's finding the least common multiple. So it's going to be a little bit different. We have to add something to it. So we're going to practice using these 2 methods, listing and doing the table method. And then on the second page, you're going to do which one you like better. But I need us to show our work for both methods. So what I write on the board, you write on your paper. So we're not goofing around. We're not doodling. We're not trying to work on the second page. We are all on the first page. We are all following along and writing what I'm writing on the board. So our first one is using the listing method. So I need to list the multiples of 6 and list the multiples of 8. Who can tell me the multiples of 6 up to the 10th one? Jimena.
1.
So 6 times 1 is 6. 6 times 2 is
12.
6 times 3.
18.
6 times 4. 6 times 5. 6 times 6. 6 times 7. 6 times 8. That's all I have room for. So I'm going to stop there and see if I have to go any farther. Who can list the multiples of 8, starting with 8 times 1? Layla. Okay, we're going to stop there. Our second step of the listing method is to find what multiples they have in common. So I'm gonna circle what they have in common. So 6 and 8, 12, 16, 18, 20. Ooh, I see two 24s, 30, 32, 36, 40, 42, 40, 48, and 48. Now, I found two multiples they have in common. Which one is our least common multiple? Zelda?
24.
24. That is the smaller of the multiples that they have in common. That is my answer. Now let's do it for 12 and 9. So we need to list the multiples of 12 and list the multiples of 9. Who can list the multiples of 12? Madison.
Okay. 12, 24, 36, 48, 60, 72, 84, 96.
And we're going to stop there. That's all we have room for. Who can list the multiples of 9? Ruby.
9, 18, 27, 36, 25, 54, 63, 72.
And we're going to stop there. That's all we have room for. So now my second step is I'm going to circle what they have in common. 12, 9, 24, 36, 27, 48, 36. Oh, I see two 36s. 48, 45, 60, 54, 72, 63, 84, 70. Oh, 72 and 72.
Oh, I thought you meant.
So they each have a 36 as a multiple. They each have a 72 as a multiple. What is my least common multiple? Ava?
36.
36. Now let's do our last one. 8 and 10. Who can list off my multiples of 8? Melanie.
8, 16, 24, 32, 40, 48, 56.
That's all I have room for with this. Sometimes we have to go farther. Sometimes we can stop there. What are my multiples of 10? Connor.
10, 20, 30, 40, 50, 60, 70.
That's all I have room for. Let's see if we can find any common multiples in here. We've got 8 and 10, 16, 20, 24, 30, 32, 40, 40, 50. Oh, I see 40 and 40. 50, 48, 60, 56, 7. That's the only multiple I have with the list I made. So it's kind of easy. Which one is my least common multiple? 40. Listing makes sense? Okay. So now it's the table method. So let's see how we use that table method. We used it for our greatest common factor. Now we're going to use it again, but we're going to add to it for the least common multiple. So up here, remember we had the two numbers that we're starting with. So we have 7 and 5. We're going to make that table. So we've got 7 and 5. I'm going to do the same thing I did yesterday and see, are there any prime numbers I can pull out of 7 and 5? No. There are no primes to take out. The added step is whatever is left at the bottom, the primes at the bottom, we multiply those along with the primes that we take out. So if I didn't take anything out, I'm just multiplying the two primes I have left. So what is the least common multiple of 7 and 5, Zelda?
35.
35. Because those are the only primes I was left with. So the least common multiple is multiplying together all of the primes, not just the ones that we pulled out on the left. So let's look at 6 and 14. Can I take out a prime of 6 and 14? Callie,
2.
I can take a 2 out. 6 divided by 2 is 3. 14 divided by 2 is 7. Can I take out any primes from 3 and 7? No. So finding the greatest common factor, I said, oh, it was the 2. When we do least common multiple, we want to make an L for least common multiple. And we're going to multiply all of the primes that are left. So 2 times 3 times 7. 2 times 3 is 6. 6 times 7 is 42. So our least common multiple of 6 and 14 is 42. Does that make sense? So if we look at our multiples of 14, so multiples of 6, we know we're 6, 12, 18, 24, 30, 36, 42. Multiples of 14, we've got 14, 28, and 42. So if we had listed them out, we would have gotten to that 42. Doing the table, we get to the 42. So now we've got 3. We've got 4, 10, and 16. What is a prime that I can take out of 4, 10, and 16? Anna Mae.
2.
2. 4 divided by 2 is 2. 10 divided by 2 is 5. 16 divided by 2 is 8. Can I take any more primes out?
Yeah.
What can I take out?
You can take out 2 from the A. Or no, 4. You can take out.
I can take out a 2 out of the 2 and the 8. 2 divided by 2 is 1. Can't take a 5 out, so that 5 comes down. 8 divided by 2 is 4. Can I take out any more primes? Layla, what can I take out? I can take a 2 out. So can't take it out of the 1 or the 5, but I can take a 2 out of the 2. 4 divided by 2 is 2. So now I need to multiply everything in the L for the least common multiple. 2 times 2 times 2 times 5 times 2 times 1. It's going to be the same. Connor. Oh my goodness. Thank you, Connor. So look what would happen there. If we take that 2 out, we would get a 2 and then a 1. So it's really, because we divide it down to that 1, it's really not changing anything because 2 is a prime. So it is down to the prime already. So we don't need to divide it by 2 because 1 times 2, 2 times 1, it's going to be the same thing. So now, what is 2 times 2 times 2 times 1 times 5 times 2? What is it?
40.
2 times 2 times 2 times 1 times 5 times 2 is 80.
Oh.
Because that's 16, 80 divided by 16 is 5.
Yeah.
80 cannot go into 40. We can't do 40 divided by 16. So, Connor, over here, I did take out that 2. I should have just kept it. I didn't have to take that 2 out there because it just could have flipped either way. Okay? Does that make sense? So when we did the table method as the greatest common factor, we only multiplied what was on the side. Least common multiple, we make our L for the least, and we multiply everything in the L. Okay? So for our homework, you can decide, do you want to list or do you want to do the table method? So you're going to either way. I don't want you to look at them and you go, oh, I know this mental math. I'm just going to write the least common multiple. Nope, we are practicing our methods. So we show our work. You have to show me if you're doing multiples, listing them, or if you're doing the table. Do not just give me an answer. Don't just look at 5 and 9 and go, oh, the only number that 9 goes into that has a 5 and a 0 and 1 side. Oh, I know that one. Okay, show me. Prove it. Okay, you have to prove it. Then on the bottom, we're reviewing the greatest common factor and the least common multiple, making sure we know the difference. Factors, that's when we break it down. Factor buddies. Multiples, we multiply up. Multiply by 1, by 2, by 3, by 4. Ava.
Oh, well, I have a question about the table method.
Yes.
So what would happen, for 12 and 14, can't you put 4 and 2 into both of them? Like which one would you?
Can you put 4 into 14?
No. Well, what would you
So-
do if you could put 2 and 4?
Pull out the 2. That 2 is a prime. Is 4 a prime? 4 is not even a prime. So pull out a prime number and see what you're left with. 12 divided by 2 is 6. 14 divided by 2 is 7. Can we pull out any more primes?
Yeah.
What could we pull out?
2, yeah, 6.
So 6 divided by 2 is 3. 7 is a prime. Multiply your primes together. Okay? All right, if you're watching this at home, we hope you are well. We hope to see you soon. Have a wonderful day.